Okay, we are on our last section. This is so exciting. You know, we're going to start here with just a basic review. If you have two fractions here, you were solving this, what would you do? I'm hoping you say you would cross multiply. That's what I'm hoping you would be saying. And I'm pretty sure all 15 of you are, 14, I can't remember, are saying that. And then you would distribute the 3 times x, 3 times -2. And you would subtract 3x. 2x equals -6, divide by 2. And nice and easy, you would get x equals -3. That's review. And hold tight for a second. Before I go on to this part, I want to ask you a question. If I told you this, what would you tell me x was? Hopefully you're all yelling at me saying 3. That's good. That's common sense, right? This has to be 3. 3 over 9 is going to be equal to 3 over 9. So I want you to keep that in mind, that when the bottoms are the same, the denominators are exactly the same, we can set the tops equal. Because that's what's going to happen down here once we get to these. Notice we're adding now. It's not just this where you can cross multiply. We've got that added in. So now we're going to use a little slightly different method. First thing, least common multiple. And we talked about this before. We need the bottoms to all be the same. And we want everything to be in there at least once. So I've got the x plus 1. Got an x. But I got an x there. So that's covered. I don't need to write that one again. Oh, but I got the 2. So I gotta have the 2 in there. So really it's 2x times x plus 1. That's our least common multiple. So I need to look at each of these now and say, okay, what do I have to multiply this by to get my least common multiple? And the answer would be 2x. Do the same to the top. Then I go to the next one. I say, okay, what do I have to multiply this by to get this? Well, I've got the x. I just need the 2 and the x plus 1. And lastly, you go to this one. What do I need to multiply this by to get this? Okay, I've got the 2x, so I need to multiply it by the x plus 1. And the reason we're doing that is, watch, I'll show you. 2x times 2 is 4x over 2x times x plus 1. Plus, I'm going to multiply those right now. 2 times 3 is 6 times x plus 1. All over 2x times x plus 1, right? Equals 5 times x plus 1 all over 2x times x plus 1. Okay, so look at the bottoms are all the same now. So I can just take the top and work with that. So I can go up here and do 4x plus, and I'm going to distribute this 6 through to both. 6x plus 6 equals, distribute that, 5x plus 5. Combine like terms. Move the 5x. Move the 6 to the other side. Divide by 5. And we have our answer. Okay, so that's kind of our goals. We're trying to get the bottoms all the same, and then we can just work with the top. So the LCM in this one is going to be what? Just x squared, isn't it? The highest power we have is the x squared. We want to take the highest power. So what do I multiply this by to get x squared? X. What do I multiply this by? Nothing. It already is it. What do I multiply this by? Okay, so rewrite it. So I get 4x over x times x is x squared minus 3 over x squared equals x squared over x squared. Are they all the same? Yep. Now you can take the top. I see the squared, I'm thinking, okay, we're going to have to factor, I bet. So I'm going to move these two to the other side. So I'm going to add the opposite to both sides. And I'm going to put that on this side. And we are going to check what plus what equals -4 and what times what equals a 3. 1 and 3. Negative, negative. I'm going to think that works. Yep, it does. So I am going to have x minus 1 times x minus 3 equals 0. And remember, our 0 property said that one of these has to be 0. So that means either x is going to be a 1 or a what? 3. Very good. All right, one more of those. Now, first you have to notice, though, here, this is a little trickier because we're dealing with the plus and minuses down here, but also because this is a difference of 2 squares, isn't it? So let's look at that and break that down factoring-wise, like you guys know how to do. X plus 1, x minus 1. And now, what's the LCM? I already have the x minus x plus 1. And also there's an x minus 1. So they both sides have to have that. This already does, so this side's really done. But this side doesn't have the x minus 1. So I need to multiply that and that by x minus 1. Okay, so let's do that. So I'm going to actually distribute right away here and get my 2x minus 2 all over x minus 1, x plus 1. X minus 6 over x plus 1, x minus 1. Bottoms are the same. I can work with the top. And I'm going to subtract x. I'm going to add 2. And we are left with a -4. Feel free to listen to them again if I'm going a little too fast. Just telling you what an extraneous solution is. An extraneous solution is when the bottoms are 0, because of course you guys know that's undefined. So an extraneous solution, for example, would be -1. Okay, -1 here would make that. It would make it a 0 equals a 0 on the bottoms when you put a 0 in up here for these. Okay, so that would be an extraneous solution. So it's kind of like when we thought about the domain and what that could be. It's similar. All right, one last grand poobah problem, and it's a doozy, I should say. Okay, so we got these 2 copy machines, you guys. Well, let's read it first, then I'll explain it. Copy machine A can make 200 copies in 60 minutes. Copy machine B can make 200 copies in 10 minutes. How long will it take both machines to work together to make 200 copies? Okay, so we've got these 2 machines. They tell you how long it takes each of them to make the same amount of copies, and then they're asking you for that same amount. So we are, in this problem, going to think of our job as completing 200 copies. Okay, so that 200 isn't really relevant at this point. We are thinking of that as a whole. We're thinking of that as a job. When those 200 copies are done, we are done. But now it's saying, how are we going to do this? Well, if you take the rate of copy machine A and add it to the rate of copy machine B, you will get your complete job. Remember, our complete job we can just think of as like a whole. When we get the whole, we are completed. Okay? So, let's look at the rates for a minute. This one. So the 200 really isn't relevant right now. We're looking at the minutes. It can complete the job in 60 minutes. And the other one can complete it in 10 minutes. So how much of the job is done in 1 minute? How much of the job is done in 1 minute for this one? 1/60th of the job is done times however many minutes. Okay, So that's per minute, 1/60th per minute. So we're getting a rate there. How much of the job is done in 10 minutes? I'm sorry, back it up. How much of the job is done in 1 minute for this one? 1/10 of the job. And the rate is 1/10. Okay, so that's all for to complete a whole job or 1 minute. We're thinking of it like that. So now we just need to combine these. So when we do this, we get a common denominator. 1/60m plus 6/60m equals 1. That's 7/60m equals 1. Oops, let's get on the screen. Times it by the reciprocal. Voila. Isn't that cool? It's going to take about 8.5 minutes to complete it. Okay, 8.5 minutes to complete that job with both of them working together. All right, so it's a little tricky. Might want to listen to that one again, but we're done. Can you guys believe it? Crazy. Take care. God bless you all. Bye-bye.